welcome to yet another episode of Growth Unplugged. I'm Nikhil Joshi from SNCC Solutions, your host for this podcast. Today, I have a very special guest with me, right from San Francisco, California, Timothy Skowronski. Hi, Tim.
Hey, how's it going? It took a little while for us to connect, but I'm glad we are able to have a conversation.
Absolutely. Tim, for all our listeners, is from a company called Planet. I love the company's name, it's just amazing. It,
All-encompassing kind of name, huh?
Exactly. I was telling Tim earlier that he is one of the people instantly when I saw him and I spoke to him, I said we could talk for hours and hours. I'm hoping that we can finish this podcast recording on time, Tim.
I'll try my best.
Let's start by setting a framework. I think it's very interesting that today we're going to be talking a lot about what's really happening in the world. Space has suddenly become the exciting frontier again. The last I remember was watching the movies about Apollo, etc. The 60s and 70s were just so exciting in the US about going to the moon. Suddenly, the last few years have again put the perspective back to aerospace, space, and innovation in general. Where we can start, Tim, is that why don't you tell us a little bit about what you do? What does Planet do?
Yeah, I'd like to correct you and say space has always been interesting and will always be interesting. I grew up a Star Trek The Next Generation fan. That's what got me into science and engineering. Eventually, I found my way into aerospace and into space and the new space economy in particular. What do I do at Planet? Planet, also known as Planet Labs, we do low Earth observation. We basically take pictures of the Earth's landmass. We have multiple products. One, I like to call our time machine product. It's a picture of the entirety of the Earth's landmass once a day. What would you do with that? Great question. So you can do change detection, right? You can see the rainforest burning in real time in Brazil or logging roads being made. You can see the receding nature of the polar ice caps and glaciers. You can look at shipping traffic in and out of coastal waterways. You can look at crop growth and do potential like crop growth yield modeling. You can look at the density of forests and things like that to calculate the impacts on the climate. How we take those pictures is through one of two different satellites. One satellite is called the Super Dove. It's about the size of a shoebox. It's called a CubeSat, even though it's a rectangular prism, bit of a misnomer. It weighs about, say, 10 pounds. We build and launch 40 of them a year. We have hundreds of them in low Earth orbit. They're passively flown. Essentially, we can orient them based off reaction wheels, motors on the inside of the satellite, or torque rods, which are electromagnets that align with the Earth's electromagnetic lines. Flying into the atmosphere because it's low Earth orbit, which still has some atmosphere, mostly atomic oxygen. So there's drag associated with the satellite. Depending on the orientation, we can slow it down. So we take pictures using the Super Dove platform. The pixel size on the Earth is 3 meters by 3 meters, so 9 feet by 9 feet a pixel, medium resolution. Then we have another class of satellite called SkySat, which is tip and queue model. Basically, you can order specific GPS coordinates and we'll get you a higher resolution offering. We just launched 2 newer satellites, one called Tanager that looks at hyperspectral emissions, mostly focused on methane emissions. So this is important for climate science because CH4 methane has like 16 times the greenhouse gas impacts of carbon dioxide. That's the Tanager satellite. I'll get back to what a bus is. Using the same bus, we have launched a couple Pelicans, which is our higher resolution offering, which we designed and built in-house in our spacecraft factory in San Francisco. What do I specifically do? I run the supply chain, test engineering, and production. Inside of production, there's manufacturing engineering, there's production, quality, all those different functions. The teams that I'm fortunate to run essentially are the execution engine that takes our brilliant designs, procures orders, creates contracts, assembles, and then gets them to the launch site for launch. That's what I do.
You essentially build satellites and you're responsible for actually the satellite.
Yes, I get to sit adjacent to, go in all the time to a clean room. I spent a lot of my career in the clean room. Early in my career, I worked at Intel for a handful of years. That was very clean room heavy, semiconductor manufacturing. It feels like Willy Wonka's chocolate factory, right? People walking around in the clean room suits. I get to sit in this very science fiction-y kind of office setting. The team that I run literally builds the satellites as I'm able to watch. I contribute where and when I can, but that's not my primary job to make the satellites. I would probably break more things than make more things if that was the case. I sit in a clean room factory in downtown San Francisco where we make the satellites, and that's what my team does.
Wow. That's awesome. I think you set already the stage for our listeners that this is a very exciting space, especially when I look at youngsters. Satellites, space, I think the purpose usually is a no-brainer. I want to touch there and ask you from a young age. I used to be very excited about watching cartoons like the Jetsons or etc. Or we grew up watching Star Wars, and many of the things now we can visually start seeing it in reality. What was your purpose or passion? What are some of the things that you did like a youngster which has always kept you excited about the industry you're in right now?
I think I will have a meandering answer if you'll indulge me. I'll start with saying that it's only with the virtue of hindsight that there's coherency to my path. That's probably the same for a lot of people. So it's like point A to point B. If you go backwards, it's a straight line. Sorry, point B to point A. From point A to point B, it's definitely not, because you come to this nodal kind of structure. One of the classes that I took in undergrad was really instructive to my outlook on life. It was decision sciences, and creating decision trees based off of probabilities really helped me think about decision making, right? As you're going from point A to point B, you enter a node where you have a decision. You can go left, you can go right. Then decision, it grows exponentially as you go from left to right. As you look backwards, it's only one direction. In my career, what I've done is really tried to make decisions that give me more decision making ability, more nodes to go left or go right. I see a lot of value in the ability to make decisions and the ability to choose my course. As I'm building skills, I think about things as like a toolbox, right? You have this toolbox and you want to put as many tools in the toolbox as possible, like equating skills to tools. So you put the tools in the toolbox, and then essentially you're playing into that saying, luck favors the well prepared, right? As you're going from point A to point B and you're trying to multiply the number of decisions, there's no decision to make if you don't have the skills to pursue a certain path. Focusing on the process, the journey of acquiring skills is something that I've really fallen in love with. Lucky things happen, but it's not really luck. It's just that work that you've put into doing or being able to have those tools. Does that make sense?
Yeah, it does. If that's the case, tell us. I'm always curious to know, does it really fall into like the aerospace industry, space, defense? There's just a lot of words out there.
Yeah, it really depends on like the customer and the end application. Planet, we sell data to scientists,
Mhm.
to commercial customers, and to defense and government. I'm not going to go into like specific book of customers and
Yeah.
governments and things like that, but it really depends. I would classify it certainly in aerospace, as the word space in it. The way that the new space economy and the new space companies are approaching things are decidedly less big aerospace than what you would think. With like cost curves, Moore's law, everything tends to reduce in cost and
Mhm.
get smaller over time. The same thing has happened with a great number of sensors and battery technology and all sorts of things that have allowed companies like Planet to exist, to move fast and to create satellites that cost hundreds of thousands of dollars, not hundreds of millions of dollars.
Yeah.
I think that's probably the single biggest thing that has driven the new space economy, not only the reduction in launch costs by companies like SpaceX and Rocket Labs, but also the reduction in size and cost of the sensors. Back to that initial question, is it aerospace? Is it defense? What is it? It almost feels like it's a new category under the aerospace umbrella because we do things in a decidedly different way. I do a lot of tours in our Willy Wonka chocolate factory space satellite thing. Important people always come through. They want to see where's the secret sauce, show us all the awesome stuff. I went on a couple tours with Will. He's just awesome, brilliant scientist who has a magic way with words. One of the things he pointed out is like big aerospace, we have 100% success rate. We never fail. That's not us at Planet. At first, you're like, whoa, that doesn't make sense. Why, like, you just throw money away? Will said, if I look at our success rate and it approaches the 90s, like we're successfully launching working hardware 90+% of the time, we're doing something wrong. Are we doing something wrong? Oh, we're not taking enough risks, right? We are probably going too slow. We're not trying new enough technologies. We're not trying to strip out the costs. We're not trying to create new and novel ways to beam data back down with funny novel antennas, right? When he sees that success rate going up, that's a sort of a leading indicator for him to say, or actually a little lagging. We're not doing things the Planet way, which is agile aerospace and to take risks. Circle all the way back to the question, what what is it? It feels like it's a new thing. The smaller companies that are moving fast and creating observation technology in low Earth orbit. It hasn't got an official new name yet. Definitely aerospace, but it feels new, right?
I think I should do a podcast sometime with Will too. That would be interesting
He's
here.
he's awesome.
What I hear there is, I think the new age, the agile way is you want to fail fast. You want to keep failing. You can fail and take basically another 20 years, which is going to be very costly. But if you could figure out a way to fail fast, then that's going to be much more cost effective in the long run. I guess that's one of the core values at Planet that you keep striving for. Awesome.
Well, especially when you're developing a new hardware product, the very first problem that you find in the field, let's zoom back. Let's say we're making a satellite and we're creating a new propulsion system. We have a new telescope in the satellite. We have new guidance and navigation controls, right? Let's say throughout the course of the design and building process, we've identified a problem with the telescope. You're forced at one of those nodal decisions to say, do we keep going and launch this satellite even though we know we're going to have this problem? Or do we fix the telescope problem and then launch the satellite? The very first problem that is not the telescope, you're going to find it on orbit. There is almost always value in proceeding down the path, especially in the technology demonstration vehicle, to find those problems, as many as you can. You should view it as an investment in the development process, even though you have a problem in it. As far as evaluating the risk, there's nuances to, is the problem big enough? Should it be a mission killer? That's what a lot of our internal discussions are around. We're always finding problems and we need to assess what those risks are. Should we keep down the path of building this thing and launch this thing so we can learn or not?
I studied industrial and systems engineering. I had a subject called
Me too.
You did too? Okay.
Yeah,
So it's just two industrial engineers talking.
the coolest of the engineers, obviously.
Absolutely. I think, I don't know whether you took a course, but it was engineering economics. What you described there is when there are a lot of unknowns, it's pretty much like our economy and economists, right? They're playing with a lot of variables and resources are scarce. What do you prioritize so that you make the best efficient resource? Seems like you are basically at the forefront where you have to take those decisions. Depending on the decisions that you take there, it could make or break or prove that the satellite is going to be very costly or it's going to be much more effective. I want you to take a shot if you had to organize the industry, right? Different people look at it different ways. For somebody who's listening and has no idea about the aerospace industry, the space, and they're just getting started, how would you basically draw a hierarchy? Obviously, there's US government, then there are this bunch of people, there's NASA. These are the standard names that people hear. Everybody hears about JPL, but without naming anybody, if you had to say, hey, this is layer 1, this is layer 2, this is layer 3, why don't you take a stab? I'd be curious to see as to how do you see the picture.
Yeah, I think it's relatively new that there are so many commercial space entities, so many commercial space companies.
Yeah.
Previously, the hierarchy was essentially the US government, Air Force based research development stuff, and NASA, who would commission, design, build, launch missions primarily for exploration, sometimes science for science sake, inventions that bleed into the rest of society, those kind of things. As I mentioned earlier, the cost of launch reducing and the cost of sensors reducing, commercial companies have started to spring up, right? With the evolution of any kind of new industry, this expansion and contraction thing happens where most companies go nearly fully integrated when they're creating something in the new industry, right? Fully vertically integrated would be something like we design in-house all of our sensors and we build it ourselves. Maybe we also build the rocket that we launch it on. We also have mission ops that controls all that's NASA, right? They did all of those things. The industry then contracted in a way individual companies do individual slices of those things, right? The Planet is decently integrated, vertically integrated in that we do our design in-house. We build our satellites in-house, assemble. This is a little bit different. We don't really manufacture many things. We are assembly, test, and integration, which is we have a fully featured supply chain that we contract with, pull the ingredients in the house, and then put them together and make a satellite. We don't build our own rockets or engines. We go to a launch provider, but then we also have mission operations. Every one of these things, there are companies out there that do these individual slices, right? There are companies that manufacture just buses. I'm going to pin bus a long time ago in the conversation. I'm going to pull it back. A satellite is generally comprised of a bus, which is the vehicle, and a payload. The payload can be like lasers or missiles or telescopes or something like that. And the bus generally has the guidance, navigation, control, and propulsion systems built into it. So there are companies that build buses. There are companies that build payloads. There are companies that integrate these two things together. There are companies that launch. There are companies that build rockets, and then there are companies that build propulsion systems that go on the rockets. Then there are companies that you can contract with for your mission operations to control the assets in space. There are even companies that create the ground station. The ground station is basically a satellite dish on the ground with computers strapped to it that receives the data back from space and then routes it to where on the Earth that we actually Planet creates our own mission. We have our own mission operations and our own ground stations that we design and deploy. At one point, we had people working for Planet that lived in Antarctica, which is crazy. We don't really do that
Wow.
anymore. I don't think they lived in Antarctica. They went back and forth a little bit. How would I categorize in the space industry in general? So NASA still does a lot of that pathfinding research. We actually partnered with NASA on our Tanager satellite because we used their technology for the hyperspectral telescope that's in the Tanager satellite. They do a lot of pathfinding stuff. They still do their own missions. We don't have a space shuttle anymore. We're in the middle of trying to figure out what's the next space shuttle, right? A lot of that technology can be used in commercial industry with licenses or partnerships, like how we did with JPL. These space companies, we're still trying to figure out, should we be fully vertically integrated, or is there more value to do your own thing, or those like horizontal slices in the business? Is that an easier business to pursue? There are some vertically integrated space companies, and then there are a bunch of different smaller sliver ones. In Colorado, there are several companies that make buses and do propulsion systems and things like that. We're in a phase of the industry where we are really trying to figure out what's the best business model and how do we pursue, we as an industry, what's the best sort of path to follow? Does that make sense?
Yeah, it does. I relate that a lot to the automotive industry.
For
Been
sure.
going through a cycle where if you are doing assembly testing, it's more like the OEMs, you know, the Ford, the GMs, the Tesla, where actually they're not manufacturing everything.
Tesla's pretty interesting in that they invest a lot of money upstream in the supply chain, like giga casting, right? Tesla says giga in front of something, it just means really big. They have really big casts
Right.
that take the place of folded sheet metal and welding and all these different things.
I
They
think
they invest a lot of process technology.
that's very similar to doing a little bit of 3D printing, right? They're trying to come up with the whole cast all at once, unlike
Yeah.
in parts. Yes. I think the one thing that is interesting in this podcast is for anybody who's listening to this, I'm sure they're getting a crash course. If somebody wants to know what a satellite is, I think you just nailed it very nicely in a very simple form. Modern technology, the way the manufacturing is changing, I think you gave a very good example of that. Earlier cars, they all basically had a lot of disintegrated pieces, but with modern technology like 3D printing and all, there's a lot of things that you can build faster. I want to ask you, because you're on the manufacturing operations side, is there anything from a modern manufacturing process that you or your suppliers today use that is helping you build much better and maybe cheaper satellites?
I wish I had a better answer for this. Much of the work that we do in our satellite production is very much done by hand. The reason why a lot of the things that we do by hand is we produce in relatively low volumes, right? In a banner year, maybe we make 100 SuperDoves and launch 100, right? The replenishment rate's like more like in 40. We could make 40 satellites in a week if we wanted to with our production team. Let's say we did that in 1 week and then we have 51 weeks where we're just like sitting on our hands. We go a little slower than that. It's relatively low volume. That lends itself to more manual assembly and maybe light automation. We do have a lot of automated jigs and fixtures for like battery assembly and things like that. But for the most part, it's manual assembly. The interesting upstream supplier technologies that I wouldn't mind speaking about are solar cell manufacturing, right? That's semiconductor manufacturing. They use a bunch of different chemistries and different process techniques to really increase the efficiency of the solar panels. There's a lot of interesting work that happens upstream with motors, with our reaction wheels. Basically, most satellites have a bunch of different motors that uses Newton's third law, right? As the motor spins one way, the satellite is going to want to tend to spin the
Yeah.
other way. So you have a bunch of them in there. You can orient the satellite. Those are really high quality, expensive motors that go into these things that require copper winding technology and those kind of things. Then we have really proprietary high precision antenna that are used on our satellites to beam the data back down. Those use interesting ways to bend metal at suppliers that we partnered with. and created those fixtures. We don't do a lot of the manufacturing ourselves.
I'm
And
guessing that requires a lot of precision, right? That bend is not like a simple bend.
it's definitely not a simple bend. I think that it makes it interesting for us as an organization. Sometimes when people think about manufacturing or manufacturing factory workers, they think of somebody that's just like putting a piece of metal and pushing two buttons and getting their hands out of the way, right? Or packing boxes, right? But our manufacturing technician workforce is super and highly educated. We have people with engineering degrees on our factory floor that assemble and test our satellites. They have to have this intimate knowledge of the design to understand how it works, to put it together. When it doesn't work according to plan, to debug and figure out what could possibly have gone wrong in this process and how can we make it better moving forward. That actually makes my job more fun and interesting to work with such a brilliant workforce, top to bottom. Everybody's super smart at Planet, from technicians on the floor all the way up to brilliant Will, the CEO, right? It's a fantastic workforce.
Do you also get hands on then on the floor, just take up and do something?
I do when I can. I need to do like strategic planning. What should the organization look like this quarter, next quarter, following year, that kind of thing. Boring budget stuff like dollars and cents. One of my organizational philosophies is I myself try to help solve the most important problem every single week. In that way, I try to be as involved as I can with problem solving on the floor to speed things along. Sometimes in an organization, even if you don't have a lot of hierarchy, there's like seniority. People don't feel the right level of empowerment, even though we as leaders try to empower people to make decisions. Sometimes it's just hard to make a decision or it's stressful. If I can come in and roll up my sleeves and work with the team to solve engineering problems and push for solutions, it really just tends to speed things along. As far as like actually turning wrenches and assembling things, that's not always my strongest ability. I leave that to the people that do that every single day. They're definitely better than me at that kind of thing.
I want to talk a little bit about your customers. The perspective that I want to talk with is, let me give you an analogy. In many other industries of manufacturing, as a consumer, I'm becoming that if I go to Home Depot, for example, I just don't want like one kind of a closet or one variety. I want choice, I want personalization, and I want it fast. This is happening at least at a large scale to a lot of consumer based products. On the aerospace side, I think there's massive customization because your customers are obviously asking like for very specific, etc. I'm curious to understand about the other two things. How is your customer changing from how they were and how
Mhm.
they are right now? Think of that analogy that I gave you. Is there any change that is happening? Are they behaving just like the consumers that I spoke about?
Yeah, interesting question. As you're talking, I had that Henry Ford analogy in my head, the faster
Mhm.
horse. If Henry Ford asked his customers what they would want, they would say a faster horse. They're like, what's a car? That's crazy. Not that our customers are unsophisticated and would ask for a faster horse. Oftentimes in the past, Planet has been engineering led. We as an engineering team try to figure out what is the realm of possibility and how long would it take building those competencies, abilities, sensors, the technologies into our satellites, and then creating a product from that. For the outside listeners, it's creating a solution, then finding a problem, which is never a good thing. Sometimes that kind of technology problem solving is requisite in advanced technology, deep tech kind of things, right? Recently, what Planet has shifted or has tried to shift towards is early in our life, we had few high paying, very sophisticated customers, right? They would take essentially our raw data and ingest it in all of their own proprietary data models. People may hear pictures of the Earth, like how complicated is it? It's actually really complicated to have the Earth spinning around in a satellite going 90-minute orbits around and try to take one picture of a stationary, it's really hard. They would take our data and put it into their proprietary models. Over the years, what we've tried to do is learn and understand what potential use cases are and move from few sophisticated customers to more slightly less sophisticated customers that we could provide the value to them, moving from data to insights. You've seen that with some of the company acquisitions that we've done that are in that realm. We bought a company that had a product using our data, and then we could use that product across the entirety of the platform. I would say yes and no. We've seen that from some of our customers, but mostly we're doing it to ourselves because we want to create more products that fit different market needs, going out and getting more customers results. Actively on our part, trying to move up the value chain, going from data to insights, to change detection, to object detection on the earth that customers would find valuable and obviously be willing to pay more for that.
That whole shift that you're doing is the future, at least in the satellite space. Is it going to be the number of product SKUs that you're going to have are going to be like a lot many? You'll still produce a few of them. The product complexity is going to be a lot more. Will that lead to a lot more production complexity for you?
What you're talking about with product is manipulation of the data. At our core, Planet is a data company, right? We want to sell insights about the Earth. We want to sell you knowledge about how the Earth is different today than it is tomorrow, especially in your specific area of interest. What we try to minimize is the complexity upstream. What we don't want to do is sell a product that doesn't exist because there's no sensor on the satellite to gather that data. There's a disconnect between the physical hardware that we make and the data products that we can produce on this thing. Yes, when we go after a new market, we will go down the development path, but developing hardware takes years, right? You really have to shoot in front of the duck just a little bit with the hardware development. That's where that faster horse analogy comes in. We have to look 3-4 years down the line to say, what should we provide? What do we think our competitors are going to provide? What's going to be the state of technology and sensors? How can we put this together in a box and shake it up and then get the most insights, bang for the buck that we can by throwing things into space? That's what makes the space industry in general a little difficult. It's not only hardware and software together. Hardware and software are always hard to do, right? Software is not easy, but it's easier to make more rapid iterations with software than it is with hardware. When you have electromechanical systems meeting software, they're always out of phase. By the time the hardware gets done, you're like, damn, I wish 6 months ago I had this sensor, but this is what we have, right? If you couple that with throw it into space and it's going to be there for a handful of years, you can't upgrade it. If it doesn't work, you don't know why it doesn't work, right? This makes for much longer development cycles than a mobile phone or something like that. This all the way back to your question of how has the complexion of the customers changed? Like I said before, we're doing it to ourselves because we want to have more and different customers. We're trying to shrink these development cycles to make sure that we can provide what the market wants now, when it wants it. We started building it like 3 years ago or something like that.
Sure. Talking about data, what I want to understand from you is what I see when I talk to a lot of manufacturing leaders. One constant feedback that I get is that there's always a struggle with messy data and outdated tools, making it hard to make data driven decisions. The simple thing leaders tell me, we are collecting a lot of data, but we don't use the data enough for decision making. I've not heard this specifically on the aerospace side because on the aerospace side, I hear a lot more about there's still a lot more paper because of compliance and regulation. I'm curious to know how you manage your data. What's the one thing that's helped you organize your data for decision making? Is there some insights that you can share, Tim?
Yeah, I mentioned a lot of our assembly processes are manual, and that doesn't lend itself to data collection on orientation of modules inside of the bus, let's say. We do a lot of data collection on functional testing at the board level, system level testing, and there's a ton of parametric data that we collect. Your question about how do we most effectively organize and use this data comes down to asking for what does the data say? Right? Actively trying to use that data in decision making. A specific example is on our SuperDove satellites, we do functional testing of all the different sensors, and our testing platforms capture all of this data. What we have done is visualize that data in a trending sort of way and applied general SPC rules, statistical process control rules, right? Upper and lower control limit, Westinghouse rules of 4 points above the mean, it's out of control, 5 points below the mean, it's out of control, trending up and down, right? Those kind of things. So it's old school SPC applied to new school data collected from testers. We tried to actually make SPC charts and it became a little cumbersome, more the mindset. What we've melded is the old school brute force of let's have a meeting. We have a daily meeting where we talk about some of these things, a weekly meeting where we look at the quality data and we look back at What did the past week tell us? Is that instructive for the next week? And then we overlay that with, this is what the data is saying. This is where we're seeing the problems. This is where our JIRA tickets and our engineers are spending their time. It makes a Venn diagram. And sometimes it's, we're spending our time over here, but these are where all the problems are. It's like the melding of the people side, active management, and then using the data. It's not a ton of fancy tools. It's a lot more problem solving data mindset. How are we spending our time? And where should we be spending our time using Pareto charts and simple SPC charts, continuously asking those questions to build in that mindset. Because what I've found is you can have all the tools you want. If you don't understand why you're using them and you don't have a hunger or a thirst to use some of these things, it doesn't matter. I would rather build in that mindset to seek out what is that database thing and how are we spending our time? Do they overlap, yes or no? Versus having an awesome Kibana dashboard that just tells me what the data thinks the problem is. I'm just a robot and I don't really understand and I'm just going to go work on it, right? That doesn't work.
I see that a lot in our line of work when we do so much software implementation, so many digital transformations we see failing. The number one reason is they're just adopting the software, but not connecting it to the decisions they want to make.
As a complete tangent, I don't want to start talking about AI. I have a lot of unpopular opinions about AI. I'm painfully afraid what you just said is going to happen on a much broader scale. Then people will tend to lose that context around why are we doing this? Why is this important? How did we even get here? No, I'm just going to use what ChatGPT tells me to do.
You heard of Shigeo Shingo?
Oh, absolutely. I know he was part of the Toyota production system.
He's the one who created. Where I was going with it is that there's one very famous quote of his. We always talk about 7 wastes, 5
7 deadly wastes. Yeah.
deadly, etc. He says that the most dangerous waste is the waste that is invisible. Data and information is where, when we are on the shop floor, on the manufacturing, in my initial years of the career, I used to do time and motion studies. I used to be on the shop floor. If there was any non-value added activity like searching, and you can visually see and say, hey, that's a waste.
Yeah.
I can solve that. How do you solve something that is inside data and that's invisible to the naked eye? We go to many factories. In general, in our lives, I'm seeing, I would have a friend, they have this bunch of productivity tools that they have used for automation, but they hardly use it. And I tell them, you're applying automation in the wrong place. It's not on the bottlenecks.
I'm going to look away from you for 1 second because you're like, you've spoken to, I live my life on Apple Notes. What I do is Friday, all right, so like personal insight, and this is going to bore everybody. Friday, what I do is I plan my week day by day. Mostly I pay myself first, right? Like when you get your paycheck, you save money first and then you pay your bills. I do all my workouts first. What am I going to do with my workouts? At the top of my notes, I have these things, my organizational principles that I really try to personify and iterate with my teams. Once we agree this makes sense, get them going on it. That invisible waste is really interesting in hardware. The most vicious kind of waste is a part that exists that shouldn't exist. But it exists. Everybody assumes that like this has to be the way we do things because that part exists. It shouldn't exist. If you're not adding parts back into the design because you've stripped out too much, you're not being ruthless enough with your design principles. The 7 deadly wastes don't only apply to the factory floor. They apply to design thinking as well. That's like number 4 on my Apple Notes over here.
Wow, so awesome. That's very interesting. It's a new world, I think, is in its initial stage. For youngsters, Tim, that's their go-to place today, right? That's the next cool thing, etc. I see a lot of leaders also asking that as a requirement as coming in. What is it at Planet or in the satellite industry today? What is the advice you would give for youngsters? What should they learn? What should they build if they're 15 or 18 years old?
I'm not sure if I have good answers. I think I'm going to have like curmudgeonly old guy answer here. I'm not one of those people that would ask or require your knowledge of AI coming into a role on any one of my teams. Yes, I recognize that some of these tools will make generating purchase orders or purchase requests faster, right? Standardizing some of these things or creating a knowledge database, like how we would manually create wikis before, just have it automatically created, right? Some of the scaffolding. What I would want for young people is a thirst for first principles knowledge about the way things work. If you don't know and understand the way things work, like electrical engineering principles, how do electrons flow, creating breadboard circuits and making a robot, understanding the way electrical sensors, the way photons hit the silicon, and that translates into electrical impulses that you then throw into a bunch of chips, slap some software on top of it, and make an electromechanical system, right? First principle knowledge I think is potentially lost with the rapid iteration and development that generative AI can give us. If you don't have that first principles knowledge, what you lose is the debug portion. It's a truth that nothing ever works the first time. If you already had a head start, now understanding the first principles of what you're building, and it doesn't work, the debug process and understanding why it doesn't work and how to fix it is going to be painfully slow or impossible to do, right? So what should young people build? Whatever you're interested in, try to seek to understand that first principle knowledge. If you use any of these generative AI tools to get you that head start, understanding why that answer is what it is and reverse engineering it would be amazing bonus points that would accelerate your learning as opposed to just having the final product. See in my background here, like here's my gym. I'm in my garage. I just recently had a baby and he sold my office upstairs. So I'm in my garage gym. What powerlifting has taught me is it's not the destination, it's the journey. It's the process of building strength and resilience and fortitude, knowledge that is important. It comes all the way back to building the toolbox to make sure that you have the tools, make sure that you can take advantage of all that luck that was given you. If you take this path of least resistance and you get this head start with building things using some of these tools, you just don't know and understand how you're using it. You're not really building the tool. You have the destination, right? You have the thing that you built, but you don't know how you got there. Put that bow on it. Build whatever you think is fun and awesome. You have a passion. Understand why you're building it and how you're building it. I think that's probably the most important thing.
First principles and build something. I think this is what Tim has to say. A lot of people don't build anything, Tim. I think that's a large amount. That's good advice for anybody starting off. I think there was another guest on my podcast which says if you want to work in the aerospace industry, you need to have the engineering mindset or that passion for building things is like fundamentally required. I think you added that first principles thinking is like another fundamental thing that is required. I want to flip the question, right? People who are into art or economics, do you think they would ever have a space in the satellite industry? Not necessarily on the shop floor, build or etc., but do you think they would have a role to play?
Dialing it back a little bit, yes, building things is important. That first principle understanding and engineering mindset, because there's no singular path to building things. It's the same thing with the career, right? If you're like, start with the end, you're like, oh, I built this thing. You're like, no, I took all these different tangents. You need to be able to understand the decisions that you're making.
That's a good example because that point A to point B that you said, now I think it makes sense. An art or an economics major, I think they've caught up the skills to do design thinking, do thinking more from a
Or like
scarcity of resources or
a
something.
philosophy major that focused in logic, right? Like
Right,
what I was going to say on the less engineering technical side is everything needs to eventually be sold as a product. And that
right.
takes intense creativity, right? Marketing to the right customers or marketing strategy to figure out what potential markets could we even go to? How do we word this in a way that non-technical people can understand? How do we word it in a way that technical people can understand, right? What are the financial models required for us to make this a business, right? A lot of times engineers, I want to gold plate this and I want it plated in like platinum, all these different, that's a little too expensive. Can you use tin instead, please? There's a great number of people with a great number of skill sets that work at Planet that make it go. Not everybody is the most technical person is by design, because sometimes you can be too technical and look at things too logically and you don't have that empathy for the customer. You don't really know and understand how to market it the right way to the right people.
That is probably one of the most brilliant points that I've heard. If you had 100 engineers probably with the same degree building a product, the product would not probably made. If it is going to be made, it's going to be made from one philosophy or one perspective. The more diversity that you have, it's just going to make the end outcome in the product much, much better. That is
I
so
there was
brilliant.
I try to not comment on LinkedIn because sometimes it's just like internet slap fight stuff. There was a comment by some CEO that said, I don't have any product managers in my company. I just let the engineers create what they want. Invariably, because they know what they're working on, it's the best product. That, in my mind, is absolute horseshit because engineers will tend to solve really awesome problems. They'll come up with technically elegant solutions that maybe are unsaleable. There's no market for it. It's way too expensive because they didn't really have an eye for cost. There's always this give and take with
Yeah.
development and how much is this going to cost and how much can we sell it for? What's the value, right? I understand that that this is the most technically elegant solution, but there's no margins in that, and we need to reduce the cost. All these outside perspectives, really hard to come by with the engineering team that is doing the actual development work all the time.
That's another interesting point you bring. When I was preparing for this podcast and looking at your profile, I think you went and got an engineering degree, but you also got a business degree, correct? Did the business degree give you that sales mindset and made you humble as an engineer that, hey, it's not always about the problem solve, but I need to also see that
Yeah.
it is sellable?
Yeah. So my bachelor's industrial engineering, I have a master's in industrial engineering as well, like more innovation management.
Mhm.
I went and got my MBA and I focused in marketing and finance because
Mhm.
I wanted to put more tools in the toolbox. The more you learn, the more you learn that there's more to learn. In my career, I wanted to be more well-rounded, to know the unknowable things out there. It did precisely give me that dose of humbleness. My technical acumen isn't always the right answer for everything. There are different perspectives to a business and to create a business and to create like this self-sustaining entity that isn't just solving the most technical problems all the time. Going back to what should kids build, right? Curiosity is important, right? The curiosity of the world around us. Like, why does this exist in this way? Why does this have this form factor? Why does this UX UI look like this? Why do I interface with these things in the way that I do? In the course of building things, understanding like first principle, the physics behind it, but also how would I use this? What are the use cases? That kind of thing, right? Understanding the world around us and how the thing you built fits into that world is, I think, a way to get a dose of empathy that I think a lot of engineers don't always have. We just don't take the time to think about those kind of things.
The same thought, if we had to put it to other professionals and leaders in manufacturing today, what should they be doing in your experience to increase tools in their toolbox?
That's a good question. I don't think that there's like a singular right-sized answer. It comes back to curiosity, right? What are some of the things that you're curious about? You can have an analytical approach to it. If I look at my boss's boss, what skills does he or she have? I compare and contrast that to where am I and how do I get those skills to add the tools and toolbox? That's the destination in mind. And there's nothing wrong with the destination, but I'm a fan of the journey. What I like to do is to build tools around things that I find myself being curious about. Right? If I'm curious about something, there's a reason for that. I try to write it down. I was curious about this thing, so I don't forget to give myself this list of things to attack or tools to add that I will be successful in. I find if I focus on the destination and I want to put those tools in the toolbox, it becomes like a checkbox activity and I just don't really give a shit. If I'm curious about it, it's super fun and it's awesome, I will give a shit about it. I'll add that tool to the toolbox. It may or may not result in luck, but it's not always the case. Like I said, I'm a fan of the journey. The process of adding a tool, I get a lot of value in. And I think about it like karmic goodness in the universe. I put this time and this energy into making this tool. It'll probably help me at some point, and that's what I'm hoping for.
Got it.
Specifically, to answer a question, I think I would just focus on what are the things that you're curious about. You also have that Venn diagram overlap of, I don't know a lot about this, and
Yeah.
I encounter this a lot in my day to day. Okay, I'm going to learn about this.
There's a notion connecting all these points to when I was asking you that you went and took a business degree. I think one notion that is building up very strongly among the youngsters is if all the learning is available on YouTube and through AI, etc., if I need to learn a formula, I don't need to really go to the university. A curious question that is building up is why go? And a lot of people are just making the assumption that it's not needed anymore. I don't totally agree with that. But I think what people are trying to ask is what is the advantage that I'm going to get other than knowing some of the concepts, etc., which I can figure out from a YouTube. There's something else about the whole university experience that gives you something. If you could tell from your experience, what are they going to get if they do that?
I can't remember the last time I went to a YouTube video to show me how to do something that I still remember. It's like Neo in the Matrix. I know Kung Fu, but Kung Fu for that ephemeral part of time, maybe it's just me, but I could do that thing. Damn, I don't remember. I can always go back to YouTube, but that becomes a crutch. It's not in my mind. I think for the vast majority of people, they are not so self-motivated to really have a prescriptive course outline, to really learn and ingest and develop these skills through practice, that carrot and stick of like study, test, grades that most of us have experienced, right? there's a lot of personal growth that happens in a university setting, right? It could be on your own for your first time. It could be like your own checking account. You have to do your own scheduling. You have to learn a lot of these advanced life skills. You really have to get your shit together if you really want to be a success. You can totally learn that on your own. I think that it just reduces the number of people that are capable of doing something like that. It makes it a ton harder to really be that self-motivated person that combs through all MIT's free courses and cobbles together your own electrical engineering degree. I'm going to say something that then I'll just say it was the wrong thing to say. If you learn it that way, you're not going to learn it the right way. There's no right way to learn things. That's wrong. The way in which you learn is important. The biggest thing I got from my engineering school was how to attack problems, how to have a curious mindset that is logical and analytical to eliminate things that we shouldn't pursue, things we should pursue, collect the data, and then make a database decision on what should we actually decide, right? I don't think that I could have learned that without being immersed in that environment, being forced with teammates to solve problems and be held accountable with a grade, have that pressure over and over and over and over for like 4 years in undergrad and then 2 years in master's degree, right? That intense pressure cooker was formative. I don't think that you can really replicate something like that easily in this virtual space. I don't think it's impossible. For some degrees, it doesn't make sense to spend $200,000 to go to Harvard on a philosophy degree. Oh boy.
Hmm.
If you studied logic and then you have a PhD in like advanced robotics and
Yeah.
I could see that. Getting this engineering mindset, I don't think that it would have been possible for me to acquire this without the path that I took.
The students' view generally is that education is becoming expensive. I think you made a good point, right? Unless you see the real return that is going to come, you're going to build skills there for sure. You also said a very nice thing there, that you had to go basically take the right courses, etc. Not all the courses that are there are going to give you those returns for
Yeah.
the money that you'll end up spending. That's a real problem in the US, at least that I see. If we can cross that bridge, that is going to be great. Tim, last words as we come to the end of the podcast. How are you seeing the aerospace industry change? What does the future look like?
Boy, crystal ball time, huh? That's a good question. Cheaper, smaller, faster design cycles. I'm hoping that in one hand, sort of poo-pooed all of AI. I'm going to bring it in and say, I think it can help us accelerate in some of the early design phases. The way that I think about design is like very Darwinian, right? Maybe have two different species that we pit against each other to say, does this one work or does this one work? And then
Mhm.
survival of fittest, then it goes on. You can do that kind of simulation, iterative design rapidly with some of the Gen AI tools, especially as they're bolted onto like SolidWorks and 3D modeling and stuff like that. So I can see a world where we can design faster as the price of sensors and materials continues to drop and launch costs continue to drop. We can be bolder with some of our platforms and the things that we're trying to do in space. That tells me that it's not a reduction in people needed to do a lot of these things. It's actually an increase in folks to think more broadly and to think boldly about what can we accomplish and how can we accomplish it. Planet just signed a contract for $230 million to be a satellite provider for a company called JSAT, which is interesting for us. What it gives us is a capital infusion to build these satellites and continue down our development path of rapidly iterating things, right? Anybody out there that wants internships, we're going to be hiring really soon for a myriad of positions. They're not posted yet, but subscribe and I'll chat you up and look at your resume. The future is like bigger, faster, stronger, right? We're going to launch more things into space. We will launch different sensors into space and we'll be able to observe the Earth and categorize and index the Earth in a way that we probably didn't even think possible in the years previously.
I didn't get to ask you this, but maybe I should ask you. Do you use anything related to QGIS?
That is outside of my technical expertise. I'm
Okay.
manufacturing guy. GIS stuff, we have an entire team that is
Yeah.
not mine and definitely nothing I know about.
When satellite came into my mind, I was like, I had to ask this. There are a lot of people who are learning QGIS, a lot of youngsters. Tim, if people want to find you or Planet, how do they do that?
Yeah, planet.com, easy way. Go ahead and send me an email to timothy@planet.com if you want. I would love to interface and talk about anything and everything space related.
Awesome, Tim. Really appreciate you being on the show. I think it's a wonderful conversation. And I know that whenever we get a chance, we could just keep talking. It's just so amazing. To all our listeners, with that, it's a wrap up of today's episode. I want to leave you all with the thought that space and satellite is just going and reaching the next level of innovations. There's tons of things happening. If you're a youngster, if you're a manufacturing professional, this is one area where US manufacturing really is bringing manufacturing and the factory back to the US. I'd really appreciate you guys look into this industry. As Tim already said, they are going to be offering internships, jobs. Feel free to reach out, but don't forget to listen to this podcast and the insights that he's given in terms of what are the skills you need to build. If you go and interview with him, he's probably going to be looking for you to be curious, having built something, and know first principles. With that, Tim, thank you once again, and that's a wrap.